Good morning, guys. Today we're looking at factorizing the sum and differences of cubes, which is the next step, I guess, after looking at quadratic expressions and factorizing those things. So first of all, what does one look like? I'm going to do a general one first. So a cubed plus b cubed. You can see it's a sum and difference of cubes. In this case, it's a sum of cubes. So it's two cubes, as you can see there. And it kind of reminds you a little bit of the difference of two squares. But obviously, these are two cubes. Okay, so the rule goes, we cube root both of those terms just to get a plus b. That's out in the front brackets. And in the next brackets, we're going to have three terms. We're going to square the first term to get a squared. Now, if it's a plus here, so it's a sum of cubes, then the next term is going to be a minus. Okay, it's always the opposite of what's in there. And then we're going to times the two terms together, so we get a, b. And then the last term, we're going to square, which has to be a positive, obviously, so we get b squared. Okay, it's a bit of a rule that you have to remember, and I guess in a way, it kind of reminds you of a perfect square, except you're not doubling the two when you multiply them together. That's for a sum. If we're looking for a difference of two cubes, okay, it's very similar. The only difference, I guess, to start off with, it's going to be a minus b in those first brackets, obviously the difference. Then everything else is the same, except I said that after we square the first term, the next sign is going to be the opposite. It's going to be a positive ab, and then it has to be a positive b squared. Okay, so they're really important to remember. So we're going to look through an example now and see if we can do it. So I'm going to give us a relatively easy one, a cubed plus, let's start off with 8. Okay, so let's have a look at how to do this question. First of all, we can see it's a sum of two cubes because we've got a cubed and 2 cubed. Okay, and sometimes people like to write that underneath. It's up to you if you want to do that. But I'm going to cube root both of them, so we get a plus 2 in my brackets to start with. Now the rule goes, we're going to square the first, we're then going to minus, because it's opposite of what's in the first brackets, 2 times a, which is 2a, and then we're going to square the last, which makes it positive 4. And that's it. Okay, we're done. So you can see it's quite simple, and I guess if you want to expand it, just to double check, a times a squared is a cubed, a times minus 2a, we actually might write that out, a cubed, a times minus 2a is minus 2a squared, a times 4 is positive 4a. Then because we've got the opposite sign, we now get the plus 2a squared, so you can see those two cancel. We now get the minus 4a, those two cancel, and then we get the plus 8. And you can see all we've got left there is the a cubed plus 8. So you can sort of see where we're going with that. Okay, let's have a look at a slightly more challenging one. We're going to do a cubed minus 27. Well, actually, it's not much more challenging. It's pretty much the same. Okay, so let's start off the same. We're going to cube root both. We get a minus 3 because 3 cubed is 27. If you're not sure, just get your calculator out and you can cube root that to find out what it's going to be. Let's now square it, a squared, and we put an opposite sign, so plus 3a, and then if we square negative 3, we get positive 9, and then I've got it. Again, you could expand it out to double check if you wished. I'm not going to bother. Okay. The next one's going to be slightly more challenging. Okay, I'm going to put here challenging because this is definitely more challenging. You might want to give this a bit of a go first. Pause it as I often advise you to do with the other videos. Have a crack at it and then you can play it. But this is definitely going to be a bit more challenging. Why? Because in the brackets, it's not just one term cubed like x cubed or a cubed or even just 27. It's a plus 3. So maybe pause it, give this a go, and then play it and see how you get on. Okay, what I'm going to do, I'm actually now going to just rewrite this. I'm going to put a plus b in brackets, a squared plus, a squared minus ab plus b squared. I've just got that above, the actual rule. That's one of the rules that we looked at earlier on. That's just to help me so I know where I can put things. I can see this a plus 3 is going to be where my a is, and my x is going to be where my b is. Okay. So what I'm going to do, I'm just going to do some square brackets, and I'm going to put my a plus 3 that's my a value, plus my b value, which we know to be x. You don't have to do it that way, I just like to do it to start with, because we've got different things going on. Likewise, my a squared, well, my a is at a plus 3. So I'm going to put a plus 3 squared minus, and it says times a and b together. So we've got x, which is one term, times a plus 3. And you can put the x either side of that, as long as you're multiplying those two terms together. And then plus, and we need to square the last term, the x. So it's x squared. The reason I've used these square brackets is because I need to expand some of these terms. Instead of it just being a squared now in there, we've got a plus 3 all squared. So it's a perfect square, which we're going to have to factorize. So we're going to have to expand out. So here we've just got a plus 3 plus x. Okay, I'm going to put those in brackets. There's nothing else we can do with those terms. They're all plussing, so I can get rid of that. The next brackets, we can expand this. It's a perfect square. So square the first, times the two together, and double it. And square the last. Okay, that's our perfect square. Then minus x times a, that's minus ax. Minus x times 3 is minus 3x. And then we've got the plus x squared tacked on to the end. Now I just want to double check to make sure there's nothing I can simplify in these brackets. There's no other a squared, there's no other 6a, we've got a number by itself, ax, 3x, x squared. That's now our final answer, and hopefully that's what you got. Okay, that is definitely a more challenging question. Okay, for the next one, we're going to go a step further. I'm going to give you one like this. A plus 3 cubed minus, might do x plus 4 cubed. So this time, instead of us having a cubed minus b cubed, we've got actually a term in both those brackets, which is definitely going to be more challenging. So what I'm going to do, again, I'm going to start off by just putting our a plus b in brackets, our a squared plus, a plus ab plus b squared. Just hold on, because look, it's a negative in there, so we need to make sure it's an a minus b. So that's my fault, sorry about that. So it's a minus b brackets a squared plus ab plus b squared. Again, I like to put that there. I can see that the a plus 3, that's going to be my a value. The x plus 4 in this case will be my b value. So I can see where my substitution will be going. Okay, so the first bracket says a minus b. Now, because there's going to be a lot going on, I'm going to put those square brackets. I'm going to put a plus 3, that's where the a is, minus, and now my b is x plus 4. You can see the reason for putting those square brackets, because when we expand these out, some stuff's going to happen with those negatives. Okay, the next part of it is a squared. We know a is the a plus 3, so we're going to square that, plus ab. Now ab is going to be my a plus 3, that's my a, times the b is x plus 4, so it's going to be a quadratic there in itself, and then plus b squared, so it's x plus 4 all squared. Okay, that's a really tough question. Once we've done that, we now need to just expand a few things. Okay, expand a few things. So I guess here in these brackets, we've got a plus 3, like that. Now it's minus x minus 4. Now we'll be able to simplify some things there a little bit later on, but we'll get to that next line. Now a perfect square, so a squared plus 6a plus 9. Okay, make sure we know how to do our perfect squares. Plus our normal quadratic, a times x is ax, a times 4 is 4a, 3 times x is 3x, 3 times 4 is 12. Run out of room here. Plus this last perfect square, so plus x squared plus 8x plus 16. Close brackets. A lot going on there. Actually, those brackets, isn't it? Okay, so my very last step. Now, last time we were pretty much done, but I automatically see here I've got a plus 3 and a minus 4. So there are things I'm going to simplify. So I'm going to put in here a 3 minus 4 is minus 1. So I'm going to put minus x and then minus 1 at the end. You could put minus 1 minus x, it doesn't really matter. Now, what's in here? It's the same. So I've got a 6a and I've got a 4a. Okay, I haven't got any other a squared, so I'm going to start off by doing this. a squared plus 6a plus 4a is 10a. Now I've got ax, yep, nothing, no other x's, ax's, so ax. Then I've got 3x plus 8x, that's 11x. I've got a plus x squared. And I've got some numbers. I've got 9 plus 12. Well, 12 plus 9 is 21, and that's going to be plus 37. Okay, and I'm completely factorized as much as I possibly can. That's a really challenging question, we might just have time for one more question. Okay, one more question. Okay, now some of you might not say that this is more challenging, you might find this a little bit easier, but the way it might be set up can definitely look difficult. So I'm going to put a cubed over 8 plus 64 x cubed. If you want to pause it, have a crack at it, and then play it and see how you've gone. Okay, so hopefully what you'll notice, again, this is a sum of two cubes. You can cube root a cubed, cube root 8, cube root 64, cube root x cubed. Okay, so if I cube root, again, actually what I might do is just put my a plus b, a cubed minus ab, so a squared, should I say, a squared minus ab plus b squared. What's my a? Okay, well if I cube root that whole thing, we're going to have a over 2. What's my b? If I cube root 64, we get 4. If I cube root x cubed, I get x. So that's my a and that's my b. So now let's work from there. So we get a over 2 plus 4x. That's in the first lot of brackets. Next brackets, I want to square this a. So I get a squared over 4. Then I've got minus a times b. So I'm going to multiply these together. So if I want to put that as a fraction, we get 4ax over 2. And then we've got plus b squared. B squared is a 4x, so it's going to be 16x squared. Can I simplify anything there? I'll probably simplify a little bit. A over 2 plus 4x. And then I've got a squared over 4 minus, well, 4 divided by 2 is 2, so I get 2ax plus 16x squared. Okay, and that's pretty much about it. I mean, that's like saying a half a and a quarter a squared. But look, that's pretty much about it. So look, I've shown you quite a few different types of factorizing some difference of cubes. If any of this didn't seem too clear, once again, let me know. If there are any other questions you would like me to do, please ask me some questions on YouTube or for Aquinas Kids if you guys want to post something on Edmodo. Thanks, guys. I hope it was useful too. Yeah, have a good day.